Hello and Assalamu alaikum. My name is Fakisha, and in this video, we will be discussing microcontroller embedded system project that we have just made. And in this project, we are using Atmega 2560. That is a chip of Arduino Mega, and but we are using the sensors with it are 6 IR sensors. We have one ultrasonic sensor. We have a SD card module. We have a voltage sensor, current sensor, encoder, and an LCD. So we have made the simulation of this project, and then we will discuss the breadboard that we have done the implementation. We have made the code in Arduino IDE for this project, and at last we have made the PCB. We will discuss the PCB board as well. So starting with this schematic over here, you can see that we are using the Atmega IC 2560, and we are using the connections we will discuss in the program of this schematic. So we are using the SD card module over here, one ultrasonic module. This is the LCD we are using, and the 4-bit input we are using. And then we have over here the voltage sensor that we have made in this, and schematic, but we have actually used the SD voltage sensor module in PCB. So over here we have the current sensor. We are using the current IC that is ACS12, and over here we have 6 IR sensors. These are actually the analog sensors, but actually in hardware we have done the PCRT 5000 sensor, the array of 5 sensors, and a single one sensor separately to make the 6 sensors. So over here we have used the Ultrasonic motor driver, and this is the motor driver module. So this is actually the schematic of our project. So here is the block diagram of our project. So we have Atmega 560 over here, and 6 IR sensors are connected to these ports. 22 to 27 is the digital ports, and this is the motor driver that is connected to 2 to 7 pins of digital pins, and then motor driver is controlling the motor, the tires, and then the encoder is attached to the tires, and this encoder is getting the input from the 45, 44, and 43 digital ports. And then we have an SD card. So SD card has input output, that is connection that is going, that is reading and writing, that is SP connection is going. So this is the A50, 51, 52, 53 ports. Ultrasonic is connected to 44 and 55 pins. That is for the echo and trigger pins. And then we have LCD. These are the 6 pins for the LCD, that is analog pins, and we are current and voltage are connected to 81 and 82, and this is a push button attached to our AD0, and our current and voltage is connected to the battery. It is showing the battery status through getting the input from current and voltage voltage sensors, and is giving input to the Arduino Mega, and this Mega is giving then data to the LCD, and is the output from getting LCD. So over here you can see that first of all we have included the library of liquid crystal, that is for the LCD we are using, the 16x2 LCD. And then over here in global, that is tab, in global tab we are using, we can create the tab from over here, that is a new tab, and you can see I have made all the tabs for all the functions and that we are using in this program. So in this global tab, we are just declaring all the global integers or variables that we are going to use. So first of all, we are declaring over here liquid crystal. Then for the 5 sensors or 6 sensors, you can select no matter how many sensors you want to use. So these are actually the 6 sensors. So over here these are 6 sensors, and that we are declaring the int IR1, IR2, IR3, IR4, 5, and 6. And the pins are the pins of the Arduino Mega, and that is pin number 22 to 27. These are digital pins. And for the motor driver L298, we are using uh, these six pins of digital port, that is from 2 to 7. So 2 and 7 are the enable pins, and 3, 4 and 5, 6 are the motor pins for the respective motor A and motor B. So moving on towards the encoder part. So this is the encoder part. We are first initializing encoder with the 0, and then initializing the steps of the encoder with 0. And this is our the defining of encoder. That is, we are giving the pin 1 connection. So of digital. And then we are moving on towards the voltage sensor. The voltage sensor is connected to analog port A, and we are initializing V out by 0 and V in by 0. And then this is the 30,000 ohm and 7,500 ohm of the resistor that is made of voltage divider, that is made in the circuit that we have just seen in. You can see, sorry, over here you can see that is voltage divider made the 30,000 ohm and 7,500 ohm. So this ohm represent that. So then we have initializing the value of 0, and over here we have the current sensors pin. So current sensor is connected to analog 2 port. So these are actually then we ADC conversion we will use it in this. So ADC converter we will use. So then sensitivity we have set to 185, and ADC value is set to 0, and offset voltage is set to 2500, and ADC voltage is set 0. So then we have this SD card module connections and all declaration. So SD card is connected to pin 50 and 51. So this is actually, I think this is of ultrasonic, not of SD card. Yes, this is of ultrasonic. Trigger pin and echo pin are for ultrasonic, and this is the distance and duration for ultrasonic sensor, and this is the files and declaration for the SD card. Then we have this LCD connections over here. These are all analog pins that I'm giving to LCD. That is from A10, A11, A12, 13, 14, and 15. So these are the pins for LCD. And then we have this chip select value of 10, Meyer average 0, and this value of an average 1, and these are some declaration. So moving on towards our in a void setup function, we are just declaring which is the output and which is the input. So we have the declare over here, this is for the motor driver and the IR sensors. So motor 1, motor 2, motor 3 and motor 4 connections, the pins are the output ports. Enable is also the output ports, and the IR1 to IR6 sensor, we are taking the input from the IR sensors, so these are the input ports. Then our trigger pin of ultrasonic is output, and echo pin of ultrasonic is input. Then we have just the character that we have displayed on the LCD. This is the mono of our core mono of our group, and this is the of each participant member of the group. So then we have LCD begin in this, that will be using to display these characters on the LCD, and we are using SD card initializing over here. Then we move on towards our loop. So in this loop function, we have serial begin. There is no need of this serial begin then, just for if our Arduino is connected to the computer, we can check from serial monitor as well. So these are the data of the sensors that we are getting or not, just to check that. So moving on to this part. that is of LCD. So first of all, in the loop starts and we get a display of our team name, and then we have to set the cursor and we have to display the mono of the team. Then we will clear the LCD, and then again we will one by one with the 2-second delay we will display the name of our team members. And after that, moving on towards the ultrasonic working, we have this setting to 00, and this will show the how much distance the obstacle is away from the from ultrasonic or the robot. And if it finds that it is in the limit, coming in the limit of the ultrasonic, then our motors will be stopped. So then we have this digital pin right trigger low and high of trigger pin, and this is all the working of ultrasonic. That is distance calculation in centimeters, and the order distance will be displayed. So moving on, here is our calling of line following function, line detection function of line follower, and this function is for the stopping of the motor. That is, if 1 second. So what the function of this function of loop is that if the distance is within the range of 5 centimeter, the obstacle is that the distance of the ultrasonic we have calculated. So the our motors will be stopped. Elsewise, we will detect the line. But if the obstacle has come in the way of, then we will not see the line, but we will stop the motors. So over here we have to just display the battery status. That is checked by the voltage sensor and current sensor, and it is display where the battery is display the battery status, and then we will call the voltage function, current function, and encoder that is drives to the left motor, and that will show the display as the how much distance that has a robot has covered. So over here we have just initialized the file of SD card, that is my file SD open, and then we have given the name daq.txt. So then we have started the file writing over here. So in this, if my file has get the data, so if it's writing to DAQ or FAQ, anything you can write. So my file print, this is the battery status will be print, the voltage of the battery, current, and every data that is coming to the from the sensors as an input we are displaying over here, and then we are printing. Then when it is finished, we close the file. So then now move on towards our ultrasonic. We have discussed now voltage sensor. So in voltage sensor we have voltage function, and this is the voltage regulation function. So value is analog reading from A1 port, I guess we have selected, and then we have V out into 5 divided by 1024, and then V in is calculated by V out divided by, that is the voltage divider circuit we have made. So then we have this setting the cursor of LCD to 00, and then displaying the LCD voltage on the LCD, and here is the symbol of that is V in is coming, and so what is the voltage of that, and after 2 seconds our LCD will get clear, and the next function will work, which is of current, and current will be displayed. So in this current function we have similar to the voltage sensor, that is ADC conversion over there done over here. So ADC voltage divided by 1024 into 5. Okay, then we have a raw sensor value. We have done some filtration over here. So ADC value is equal to this, and then we have delay, and in V we are showing the millivolts, millivolts, and also showing the current over here in amperes. So then after 2 seconds our LCD will get refreshed or clear. So in this now in encoder function, what we are doing over here is just we have made a calculations for the inputs that is we are getting from the encoder. That is we have a dial over there, and after we have calculated the circumference of the tire, and we have calculated that if one reading is shown, that how much distance is covered by that tire by calculating the circumference. And so this is done by increasing. We have done the loop over here and while loop over here, and if conditions. If we get the check encoder as 1, then we add 1 into the loop every time, and if it stops, so we cannot get that 1 addition. So in this way we are incrementing how many times the encoder has taken the input. So then if we move on towards our line follower, so in line follower we have made the code for 5 and 6 sensors, but over here is this shown of 3 sensors only, because it's working perfectly. We will discuss it later. So in line sensor we have just declared the same IR sensors, which one is leftmost, which one is left sensor, middlemost. So our main logic is that we are putting middle 2 sensors, that is S3 and S4, on the line, and the left 2 are on the left side of the white surface, and the right 2 are on the right side of the white surface of the line, black line. So if we get only the middle sensor as 0, and the right and left sensors are 1, that is off the line. So our line detection sensor gets 0 input, and 1 is the white surface detection. So if we get 0 on the center line, that means that our motor has to move in the on the front. Both motor has to move at the same time in the same direction. So that is motor 1 and motor 3 inputs have to get high inputs, and the opposite is the low. So that is 180 we are giving. So if we want to increase the speed, we can go to 255. So I'm giving at a normal speed, it works fine. So what if we get the right most sensors and the middle sensor off the line, and only the left sensor is on the line? So it means we have to move towards the left and take a turn. So what I'm going to do is we are decreasing the speed so that a controlled motion can be performed, and neither it go directly off the line. So that's why we are decreasing the speed. And over here we have first the left motor is moving the same speed, same direction, but we have just reversed the motion of the other motor, so that it make a turn. One motor is moving inward and other motor is moving outward, so it makes a turn in that way to get it on the line. So then we have the other option, that is 110. That is now right sensor is on the line, but the left sensors are both sensors are off the line. So we have to again move. If the right is on the line, so we have to move the left motor in the other direction to get it on the line. So that's what we are doing over here. So moving on towards the next logic. So it is the exact same, but just this is 100 and here was 110. So we are using the same logic to take a turn over here also, and this is 001. It is same condition for 011, because we want this sensor, the middlemost sensors we want on the line. So if there are middle 2 sensors on the line, we have to do 00. If we are using 1 sensor, we are using 0 over here, only 1 sensor. So if we get all the state as 11, that is all the sensors off the line, or all the motors are gonna set to low, encoder is set to 0, that is we are gonna stop our motors. And similar is the case if all the sensors get 0 0, that is all the sensors get on the black line, it means that we have reached our T junction end goal and we have to just stop the motors. Now we move on towards the SD card function. That is, in SD card function we are using the SD begin. If the chip select is not selected, SD begin. Initializing will be failed if the SD card is not inserted over there, or initializing will be failed over there. But if we attack the SD card in the SD card module, initializing will be done, and we will open this file and we will start writing into it. So after completing the writing, if writing gets interrupted, if the SD card gets removing, error message will be appeared, and we will try to reopen the file. So we will read from the file. If we want to, we can read to this function that is made over this condition, and then at the end we have to close our file. So that was from this program side. So in this PCB designing, we have selected all the ports. So we start with the mega connections. So this is the at mega 125 connections. So over here we have connected every port with the additional seal connector. So we have used seal connectors, and this is a Molex connector for the 6 IR sensors input, a separate connection. So then we have uh, ultrasonic 4 pins connection for with the Arduino, and here we have encoder connections, and these are connection for the perf board that we have created on the PCB. Over here we have LCD connections. This is a 10K port we have used, the connection for that. Resistance we have resistor we have used, and over here we have SD card connections, and over here we have voltage sensor connections, and these are the current sensor connections. And these are some push buttons for the for if you want to select anything, any call an interrupt on the LCD and want to start the PC, start a robot. So these are for that. We are connected with the a not port, and with the variable varying of this resistors, we can create an input, any voltage decreasing input, and we can, if that input is received, specific voltage is received, we can perform specific operation in our program if we want to create it like that. And this is a buzzer sound. We can get a buzzing sound, any music, anything we want to play. And these are the connections for the ground and 5 volt that is made on the separately on the PCB. So moving on towards PCB layout. So this is our PCB layout. If I zoom in properly. So size of our PCB is 190.5 millimeter, that is 19 centimeter, to cross 100 millimeter, that is 10 centimeter. So it is quite of customized, quite of, I think I have made a small PCB for this system, but still it is a big. So starting with the Arduino Mega. So you can see this Arduino Mega, the highlighted ports. These are of the Arduino Mega that is attached to the below side, and this is and this is our LCD connections. This is our LCD on the upper side of the Arduino Mega, and this is the 10K port we are using over here, and these are the other seal connectors attached to the Arduino pins. This is the separate pins for the more pins for the LCD. If we want to, if these ports get any damaged, we can use these. And these are the ports for 5 volt and ground. These are all the double seal connectors, and these are the buttons and the buzzer over here. And this is the perf board, uh, or we can place it's the size of the mini breadboard. Actually made the size of actually on the sizes of the mini breadboard, so you can paste a breadboard over here, or you can just drill the holes and make a perf board. So here we have a current sensor location. Here we have SD card location. Here we have ultrasonic, and here we have voltage sensor. So this is the Molex connector of IR sensors. So if we move on toward 3D visualizer, so you can see our PCB in 3D. So this is, I was discussing that we have below is our Arduino Mega attached to it, and on the upper side we have this LCD, and this is the 10K port connections. These are Arduino pins connections. These are 5 volt and ground connections. These are our buttons, push buttons. This is the voltage sensor. This is our current sensor. This is the SD card, and here we have ultrasonic at the front, and encoder. We have not used this encoder. This is the rotary encoder. We have used the tachometer actually, which is attached to the tire. So, and this is the Molex connectors for sensors, rear sensors. So that was it from PCB designing. Now we move on towards the making of the whole system in hardware.